Hi, in this lesson 3.3 for Algebra 2, we are going to be solving systems of linear inequalities, which means we're going to find the regions of the graph that work for both inequalities. So we'll start by writing down the equations and solving for y so that we can graph them. So we will first subtract 2x from both sides. So you have negative y is greater than or equal to minus 2x minus 3. And lastly, we want to get y by itself, so we're going to divide everything by a negative 1. And so now we have y is less than or equal to, now notice I switched the arrows because I divided by a negative, 2x plus 3. Now when you graph this, remember this is in the form of y equals mx plus b. The b is the plane number and that is your y-intercept. So we'll put a point right there, y equals 3. And then the number in front of the x is your slope. So in this case it's 2 over 1. So we're going up 2 over 1. Or we can go down 2, back 1. And it says that it is less than or equal to. So it is equal to, so we will make a solid line. And remember to shade. We put our pen on the y-intercept, and if it's less than, the y's are less than, going this direction, which lands us on this side of the graph. So we're going to go ahead and shade that. And these always look really messy on this board. If you're using a pencil, you can just lightly shade. All right, now the next equation, and we'll pick a different color for that, is y is greater than or equal to minus 1 half x plus 1. So your y-intercept is 1 here, and your slope is negative 1 over 2. So down 1 over 2. Or up 1, back 2. It's a negative slope, so your line should be falling. And again, we have a solid line. And if we shade that, y, if we go to the y-intercept, it's shading above. And so I'm going to highlight above, and I'll use this marker this time. This might work a little bit better. And hopefully you can see that they overlap in the upper right-hand corner. And so when you're working on this, what I want you to do is to show me that you see where they overlap by darkening that area. So like just darken it with your pencil, or if you have something else to write with, go over it. So now I know that that region right there works in both inequalities. And you can test some points, like you could just pick a point like 3, 3 and put it in both and make sure it works, but it will. Okay, the next one, we have x plus 2y is less than or equal to 4, and y is greater than or equal to minus x minus 1. Now, you can graph by using intercepts, or you could solve for y. If you want to use the intercepts, when x is equal to 0, you would have 2y equals 4, divide by 2, y equals 2. So the y-intercept is at 0, 2. So then you can plot that. And then for your x-intercept, y is equal to 0. And so you would have x equals 4. And that's going to be a solid line. Now the thing about when you graph it that way, if you don't solve for y first, you can't use that little trick that we have where you say is y greater or y less than. So you actually do have to test a point. Now I will test 0, 0, and see if that works. So 0 plus 2 times 0 is less than or equal to 4. So that would be 0 is less than or equal to 4. And sure enough, that's true. So 0, 0 works, which means everything on that side works. So you can shade below the line. Now again, if that doesn't make sense to you, go ahead and solve that first equation for y and graph it the way we did on the other problem. Now this one is solved for y, so we'll graph that with the traditional way. The y-intercept is -1. Your slope is also -1, so down 1 over 1, or up 1 back. And then this one is a solid line also. So that looks like this, and it says y is greater. So it's going to be this area here, and so it's everything above the line. And let me pick a different color, see if I can get this to work a little better. It's not wanting to cooperate. Well, I'll go back with the yellow here. Still didn't work real well. There, when I use this color, you can kind of see this region in between is where it's overlapping. So this region in between would be your solution, right through there. That would be your solution, right between those two lines. That's where they overlap. Okay, next one. A pizza parlor charges $1 for each vegetable topping and $2 for each meat topping. You want at least 5 toppings on your pizza. You have to spend $10. You have $10 to spend on toppings. So that's your maximum. How many of each type of topping can you get on your pizza? So we have veggie toppings and we have meat toppings to choose from. So we'll call this X and we'll call this Y. Now, what do we know? It costs $1 for each vegetable topping, and it costs $2 for each meat topping. You want at least 5 toppings. So the total that you want to have would be 5. So if you add your X's and your Y's together, X plus Y, you want at least 5. So they could equal 5, or it could be greater than or equal to 5. And the amount of money that you have is $10. Now it says you have $10 to spend, which if you can spend less than $10, I'm sure that's fine. So if it's $1 times the number of veggie toppings plus $2 times the number of meat toppings, and that altogether, your total amount of money is going to be less than or equal to $10. And so now we're going to solve this. So first of all, these are in standard form, and again, it's easiest to do intercept form with standard form. So if y is 0, your x-intercept would be 5. So you would have a point at 5, 0. If x equals 0, your y would equal 5. So then you'll have an intercept at 0, 5. So you can plot those. So x is 5 and y is 5. And that will be a solid line. Now, actually, there are some constraints here. When I look at my graph, I'm going to erase right through here and right through here. I want you to think about why I would erase that. So hopefully you're thinking, well, these are representing the number of toppings, and anything down in this region down here or over in this region would represent negative numbers, and you can't have a negative number of toppings. So we're really only working in what we call quadrant 1, because those are all positive numbers. And now we'll test the point, and 0, 0 is the easiest to test. So if you put in 0 plus 0, is that greater than or equal to 5? No. So that does not work. So you're not going to shade on this side, you're going to shade on the other side. I'll try using the yellow first. I think that will work better for us. So you're shading this direction right here. So anything above there would be points that would work. So then the next one, if we do the x-intercept, y would equal 0. So then x would equal 10. For the y-intercept, x equals 0. So you could cover up the x, so then you'd have 2y equals 10, so y would equal 5. So the x-intercept is 10, 0. So over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Your y-intercept is 0, 5. And if we test a point there, if we plug in 0, 0, you would have 0x plus 0y less than or equal to 10. Well, that's true. 0 is less than 10. So you would shade below in that line. This is what I should have done on the last one. This worked better. So the region that works is that green region. Those are the combinations that would work here. So if we look at some of these values, 1, 2, 3, 4, 5, like 5, 1. 5, 1 is there. 6, 1. It looks like 7, 1. Or 1, 2, 3, 1, 2, 3, 3, 3. Or 4, 2. So those are just some of the combinations. And so basically, we want to have more than 5. And so if you add all of these together, 5 plus 1, 6 plus 1, 7 plus 1, 3 plus 3, 4 plus 2. So when you add them together, they're more than 5. And then when you look at the cost right here, 1 times 5 is 5 if we're looking at 5, 1. And then 2 times 1 is 2, and that would give you $7 if that's the combination you go with. Let's say you go with 3 and 3. 3, this would be $3 here. 3 times 2 is 6, that could be $9. Let's say you go with 4 and 2. That would be 4 plus 2 times 2 is 4. That would give you $8. So all of these values, everything in the shaded region right here, that works. That works for that problem that we have. Okay, lastly, what is the solution of the system of inequalities? Y is less than or equal to 3. Well, remember that is a horizontal line. So on the y-axis, we go to 3, and we're going to draw a horizontal line, and it's solid. It's not dotted. And it says y is less than. Right there. And then the next one, we have y is greater than or equal to. Okay, let's remember what these symbols are right here. Those are absolute value, which hopefully you remember. Absolute value are V-shaped graphs. And so your vertex would be at 1, 0. And so we go over 1, up 0. And the slope on the right side is a 1. So from there, from the vertex, we're going to go up 1 over 1. And then we go back to the vertex and go up 1, back 1. And to graph it, we go to the y-intercept, and it says y is greater. So that would be right here. So what that's going to do is land us inside, and the overlapping part will be just this little region right here. You're going to graph all above here, but your overlapping is just in this little triangle area right here, and that would be your solution. So you would darken that. All right, one more quick one here. The first one, your y-intercept is 1. Your slope is -1/3. So you're going to go down 1 to the right, down 1 to the right, or up 1 to the left, up 1 to the left. And this is less than, so it's not equal, so we would make a dotted line. And y is less than, so the y values that we would shade would be below the line. And I started with blue first. I forgot. I should have started with yellow. All right, next one. This is absolute value. So again, we look for our vertex, which would be a +1, -4. Remember, we switch the sign of the x or the h. So the vertex is at 1, 4. So we're going to go over 1, down 4. Sorry, that's a -4. And the slope is 2 over 1. And that is dotted also because it is not equal to. And it says y is greater, which goes this way. So your overlapping will happen right through here. And that is your solution. Okay, for your assignment, I'd like you to work on page 152, 11 through 13, 20 through 27, 46 through 48, and 59. Thanks.